Here's how to solve for related rates. So here we have an inverted cone with a radius of 5 inches at the top and a height of 7 inches. What they want us to figure out is the rate at which water is being drained if the water level is 3 inches deep and the surface level is falling at a rate of -8 inches per second. The best strategy for solving related rate problems is to first draw a picture, label your variables, and figure out which rate you're given and which rate you're trying to get. In this case, we're trying to figure out the rate at which water is being drained, so that's going to be the change in volume over the change in time, or dV/dt. And what we're given is the rate at which the height of the water in the container is falling, and that's going to be dH/dt, which is -8. Once we have our two rate variables, which is v and h, we need to find an equation that relates the two. In this case, it's the volume of a cone, which we know is 1/3 pi r squared h. However, before we go any further, we want to make sure this equation only has our rate variables in it, which is v and h. So in order to get rid of this other variable r, we need to find another relation that puts it in terms of either the v or the h. In this case, we have to go all the way back to geometry and remember that for two inscribed triangles, the ratio of the sides of the triangles are going to be the same. So now when looking at the triangle created by the water level within the cone compared to the whole cone, this means that r over h has to equal 5/7, which now gives us that r is equal to 5/7 h. Now we can plug this in for r in the original equation for the volume, simplify a little bit, and now the next step is to implicitly take the derivative of both sides. So the derivative of v is just going to become dv, and the derivative of h cubed is going to become 3h squared dh. The next step is divide both sides by dt, so now we have our two rates, dv/dt and dH/dt. Now from the problem, we know that the change in the height of the water level, dH/dt, was -8, so we can plug that in. And we're trying to figure out the change in the volume when the height was equal to 3, so we're going to plug that in for h. Make sure to check that all these units are the same. In this case, they're all just forms of inches. Sometimes I'll try to trip you up and give you one of these numbers in feet. So now we solve for dV/dt, which means that water is leaving the cone at 115 inches per second. And there you have it. That's how you solve related rate problems.
Nice!